Hello, welcome back. This is the third question, and this is also one of the toughest questions in this paper. So let us try this out. A boy stands on the end of the rigid uniform. This is uniform plank lying on the brick wall. Estimate the minimum mass of the plank. So you have to estimate. So remember, when you're talking about estimate, give me the maximum of two significant figure. And in this case, is that you need to estimate one thing for sure. You need to estimate the mass of this plank. And this plank here, let me draw the free body diagram. Number one is that the WP, the width of the plank, WP. So they will exert a force due to gravity. And secondly, there is another one. This is another force acting on the plank due to the weight of the boy. Let me call it WB. This is WP. And ask yourself, do you have more forces here? There is one more force here in the sense that there must be a reaction. Okay, and this reaction will be exerted towards here. The P here keep on missing and missing and missing. This is let's call it as R for reaction. And I can safely say that this R value must be equals to W of the plank plus the W of the boy. This one is for sure, okay, because the force up and down must be equal. Otherwise, this plank will be flying upward or downward. So number one thing that you need to estimate is that you need to estimate the mass of the boy, okay, mass of boy to be maybe 40 kilo, too significant, yeah. 40 kilo, and if that's the case, this one means that the force of the boy here is 40 times 9.8 Newton. Okay, now we can solve this by using the idea of torque again. Maybe I choose this end here, let's say point A as pivot. Okay, so A here as pivot, so I have to work out my clockwise anti-clockwise torque. Ask yourself, clockwise torque is given by what? It is given by the weight of the plank as well as the weight of the boy. So weight of the plank here is WP multiplied by the lever arm. In this case, half of the 5 is 2.5. One portion. And another portion here coming from the weight of the boy, WB. How long is it? The lever arm, the shortest distance here is 5. And that's it. That's all the contribution from the clockwise. And you have to work out the counterclockwise. Counterclockwise is given by none other than the R, the reaction. And the lever arm here is 5 minus 1, it will be 4. Okay, then you're good to go. If you apply the rotational equilibrium, sum of all the torque about any pivot will be 0, means that all the clockwise and anti-clockwise summation will be equal. Okay, if that's the case, let me make some quick mathematics. This one is WP times 2.5 plus this one is W boy is 40 times 9.8. That's the W boy, and times the 5 must be equal to the counterclockwise is R is WP plus the W boy here will be 40 times 9.8. The whole thing times 4. Okay, and I think I need to skip some step. Your main objective, find the WP. Okay, and skip some step. WP, just do the mathematics here. You have 261 Newton approximately, and you have to take the mass of the plank here by taking the width of the plank divided by 9.8. So I'm taking 261 over 9.8. In this case, my estimated mass of the plank here to be 27 kilo. So over here, this is two significant figure, and this is good to go. So for those of you who are having different mass of the ball, 35 kilo, maybe 30 kilo, 45 kilo, you will have different answer for sure. So remember, keep to two significant figure and apply the formula, and you should be good to go. Your final answer must be two significant figure.